the agenda for today's session. We are going to start our discussion on Git and GitHub. Okay, the agenda for today's session is, so we are going to start with this version control system or software configuration management, under which we are going to make use of two tools. One is Git and another one is GitHub. So here we are going to discuss about this basics of Git and its architecture perspective, how it is architecture, what are all the key words associated with the Git, and what are all the commands associated with the Git. So these are all the things that is planned for today's session. Okay, so as I told, version control system or software configuration management is used to maintain the history of your software programs or any document. Okay, so here what are all the things that is done is tracked and it is recorded. Okay, we keep tracking and we store those things as a sequence of files, as a set of files managed by SEM. Okay, for example, as a developer, if yesterday itself we have discussed, so we assume there are three developers belonging to a project: developer 1, developer 2, and developer 3. Each developer is developing a particular model in the project, and all the associated codings specific to this model. This is model 1, and this corresponds to model 2, and this corresponds to model 3. These are all three models that we take a banking project. So here the model corresponds to the credit transaction. This model corresponds to the debit transaction. This model corresponds to the loan transaction. Let me imagine the application is a banking application which involving three models. So here each and every developer is assigned a particular development of a particular models. So these models may result in developing several files, several functions, several files. Let me imagine this file 1, file 2, there are three files. Similarly, here we have a number of files. Okay, so all the files may have versions. The file 1, version 1, file 1, version 2, file 1, version 3. Similarly, so everything first initially we may develop a code and we may run a code, and the code may not work or we need to fine tune the code. Accordingly, we will do some modification on this file. The old file will be stored as a version and the new file will be stored as a version 2. Similarly, each and every time when we do modify, all the informations will be recorded and it will be stored as a separate version. For managing all those things, who is the owner of the file, when the file is created, what is the reason behind the modification has been done. Okay, so all those things will be recorded and it will be managed by this version control system. Okay, that is called Git. Okay, so Git is a tool. So GitHub is a repository. As I told, the difference between Git and GitHub is Git is a tool and GitHub is a repository. What are all the things a developer is doing here on its system need to be shared under a common place. Okay, need to be shared under a common place globally. That global location where all the files are associated, the entire file, each and every file associated with all the models will be shared under a common place. This is called as global. Okay, a global repository. Repository is nothing but a location where we store file. Here, each and every developer may store the associated files in their own system. Here we call it as a local repository. Okay. So this is the way by which here all the commands, associated commands to create a file, to maintain the version, to update. For example, if you have file F1 version 1, and if you did some changes and the file 1 version 2, so those changes need to be updated here. Or any person, for example, here developer 1 did some changes and he updated in the global repository. If developer 2 want those files, he want to download from the repository, all other thing can be done by using Git commands. Okay, so let me first, yesterday's session itself we have started with what is a version control system. Under version control system we have discussed almost all things. Just okay. So version control is the management of changes to the documents. Not only programs, we can also use documents. It's also make use of the codes associated with websites or any other information. Okay. So being with respect to time, we have frequent changes. It will record all those changes. So here you can find at a particular time you have your project index.html file alone has been created. This corresponds to a version 1 of the file. And laterly, some days after, you did some additional information. So you have added another tag about HTML. So this corresponds to new version. Then laterly, you did some changes. The page layout has been changed and it need to be maintained as a separate version. Okay. So each and every version need to be managed. What is the advantage of going for management? If at one point of time, so during this change 3, if you want to go back to the original thing, then what you can do, you can revert back all the changes and you can launch your website based upon version 1. Okay, so these are all the way by which maintaining different versions each and every time that you make a change will help us. If you want to revert back, you can revert back. Okay, this is called version control system. Okay, so here if the main advantage of going for this version control system is collaboration among the users. Okay, these are all the models that we have specified as a task. Developer 1, developer 2, we need to maintain separately. If some of the functions associated with developer 2 need to be viewed by developer 1, it need to be copied into the developer 1's machine, then only you can able to do that. So here, being everything, all the thing, being it is stored on a central repository like GitHub. Okay, all the codes associated with developer will be stored in a central repository called GitHub. Each and every developer associated with the project can able to access the code. That is called collaboration. That's what that it is specified here. The advantage of going for distributed sharing of coding is collaboration. So the task can be combined. Each and every user can able to make use of the other users code. Okay. So here is a repository, the Git repository, the global repository that we have specified will store the corresponding code version 1, version 2 in a separate entity. Okay. So here each and every version will be named accordingly. So also apart from that, what are all the changes made from version 1 to version 2 has been also recorded. We will discuss all those things. What is the change from version 2 to version 3? So that when you look into those repositories, you can able to identify for what reason the version 2 was created, for what reason the version 3 was created. So that at later stages, if you want to do some debugging or if you want to do some analytics, you make use of these versions. Okay, these are all the advantages. So the another advantage is, so this is your central repository. This corresponds to your central repository. In terms of this version control system has been concerned, there are two types of management. One is distributed version control system. The version control system has been categorized into following category: distributed version control system, and second one is centralized version control system. Centralized model. There are version control models, way by which the document has been managed. It can be categorized into two things. One is distributed, and second one is centralized. So what is centralized? Here we have, this is an example of distributor. This is the model, is an example of distributor. Here this is the server, global server. These are all developers desktop. Developer 1 is a laptop. developer 2's desktop, developer 3's desktop. Okay, developer 1, developer 2, and developer 3. So here, what are all the files that is managed here in the developer's machine is called local copy. All the files also will be managed in the server one. Okay, so all the files. Imagine the server is launched on GitHub. These are all local machines, local desktop computer or laptop computer. You take anything, local machines. What are all the files associated along with the versions will be managed in the global server also. So at any point of time, the advantage here is at any point of time, if developer 2 want to access some files associated with the developer 1 or developer 3, being it is shared in the global server, he can able to view the file and he can able to do all the things if he has given enough access permission on top of it. So what are all the changes that we made by each and every developer will be updated here. Okay, frequently it will be updated. So the advantage of going for that, even though if the server get crashed, in this case, even though if the server get crashed, no need to worry about that. So we have in our local machine all the copies. This is the advantage of going for this distributed model. On the other hand, in a centralized model, the concept associated with centralized model is we have only one server and all the codes developed by the developer need to be stored on the server only. Okay, they won't manage this architecture, they won't manage the code. So file 1, imagine by developer 1, again file 2 by developer, file 3 by developer, it will be managed only here only. Okay, then the drawback here is if the server get crashed, the users, the developer associated with the projects can't able to access those information. That is the difference between going for this centralized model and the distributed model. Please make a note of. Main limitation is, so for each and every action, if a user want to do some modification to the file, then you want to connect to the server and you want to download the file, you want to retrieve the file from the centralized server into its local machine, and you want to do the changes on top of it. And once the changes has been made, you need to version that file, and the version need to be again once again moved back to the server. So each and every time the file need to be fetched from the server and need to be do the needed change, and once again it need to be updated. So the fetching latency will be high. In this is the first model. The centralized model is the first model, and while we are going with this PCS, then laterly because of this opposite, then if a server second problem is when a user committed a mistake. For example, user created a file and he uploaded the file, and the central control being it is stored on a single repository, so directly it will have an impact of all other stored information here. Okay, the entire product will be impacted directly. Also because being this information is managed centrally. Okay, so here the entire product will be impacted. So first drawback, because of this fetching the files, the latency will be very high. The second thing, being only at the central server, only on the server being the file has been made. If the developer one develops a particular code and if we upload the code on the server, so whenever here the code already we have file 1, file 2 and file 3 associated with the 3 developers as a product. If there is a problem associated with file 1, it also have an impact on file 2 and file 3 while we combine all the 3. Okay, so that is the second drawback. Then the third drawback associated is if the server get disconnected, if the server get crashes, or if there is a network problem, so the user can't able to do any activity on the file. Whereas if it is local, even though the disconnection, if the server is disconnected, or if there is a problem, still the user being having a local copy, he can do the needed modifications. Once all the modifications has been done, once the server retrieved back to the original position, he can push all the, he can sync what are all the modifications that he did on his local computer into the server. Okay, so these are all the major advantages compared to the top going up with a centralized model and a distributed model. Please make a note. Here, in terms of this model, the centralized and distributed. So Git follow the distributor architecture. Git follow the distributor. Git follows the distributor architecture. So there is another tool called as Mercurial. It follows the distributor architecture. Here the thing that we have discussed, CVN, okay, subversion, SVN, Perforce. We have already discussed about these tools, Perforce, SVN, CVN, okay. Those tools belongs to centralized model. These are all the major difference associated between a distributed and a centralized model. Okay. Here we have initially discussed about a feature in our yesterday's session. We have discussed about the features or advantages of going for Git. The first feature we discussed is speed. This is the way when working on these Git operations. If you have data stored on your local repository, you can retrieve the data and you can do the needed changes and you can make it changed file as another version. So that is the concept behind speed. If it is stored in a centralized model in this server only, each and every activity need to fetch the data, and because of this we face some fetch latency. Okay, that is the advantage of going for this Git. Okay, the second advantage that we have discussed is so the lightweight components. So the second, support for branching. We will discuss about branching. So Git is a fully distributed model. It's the third feature. So okay, the another advantage is Git is made up of lightweight components. What do you mean by lightweight components? Lightweight component in sense, for example, you are having a file. Imagine the file is 1.java, file 1.java. Here the file containing line 1 and line 2. So here you did a change to the file and you made it as a copy, file 1.1, version 1.1. This corresponds to original file. Then whenever you did changes, so now you added a new line, line 1, line 2 and line 3. You added a new line. Here how Git manages this, whether it will copy the file 1.1 and file the second version 1.2 version all the lines. No, the answer is no. Here the Git will manage only what are all the changes that is made compared with that of the previous version, file 1 and file 2. Now it will record only the changes. It will maintain the changes in file 1.2. Okay, it won't have all the three lines. So it will have the first two lines, which is a similar line, which is not modified. Then only the new line, which is added alone, will be managed in the version file 1.2. This is called as lightweight components. Okay, if it manages all the three lines, okay, then it is called. What is the drawback associated? So if there is a no change in line 1 and line 2, it is not at all needed to manage again. It results in a file duplication. Okay, to overcome to minimize the storage space, Git follows this representation. Okay, this is called a lightweight component. If you people aware of backup, you may come across this incremental backup. The concept called incremental backup. So similarly, so what are all the difference associated between these two versions alone need to be recorded here. Okay, so these are all some of the advantages of going for Git. Please make a note. These are all interview questions. So what do you mean by lightweight component? What's the difference between a centralized and a distributed architecture like? These are all the questions associated with the interview. Okay, these are all some of the tools Git that we have discussed: Mercurial, CVS, SVN. Okay, these are all some tools. Then here, this is the architecture. These are all the local machines. Under the local machines, we have Git, and this is a repository. The server, we have this GitHub. The GitHub is the location where we store all the files associated with a particular project. Okay. So we use this push and pull command to copy from your local repository into the remote repository, or we call this repository as a global repository. Okay, the repository need to be created under GitHub. Okay, this is called as a global repository, or otherwise called as a remote repository. It is a shared repository. These are all copies associated with each and every users. Okay, these are all working copies associated with computer 1, computer 2, computer 3. So this user will maintain the copy in its local computer. Okay, in its local computer. So laterally, if you here we have a local repository. The architecture here is these are all entity belonging to the local computer. Okay, so we have a working copy. The location where the user is going to work with is called as workspace. We have a workspace. Okay, where the user is working with the Git related commands. Okay, all the files will be stored in a location. That location in the local computer where the user is currently working with is called as a local repository. Please make a note. Once it is perfect, all the activity has been successful, then you need to store those information in the global repository. So for that you need to use a push command. Okay, if the user is in need of some files associated with, here we have the data associated with user 1, user 2 and user 3 in this case. Okay, so we have user 1, user 2 and user 3, all the data will be stored here. If a user 1 need to retrieve some information associated with user 2 or user 3, which is in a global repository, you want to use pull commands. These are all the two major commands. Push command, which is used to push the content from the local repository into the global repository. Pull command, which is used to retrieve the content from the global repository into the local repository. Okay, please make a note. So here the location that we can make a note that the repository can be treated as a container. The repository can be treated as a container under which all the files belonging to a particular product will be stored. Okay, all the files belonging to a particular product will be stored in a repository. If the user stores only the content associated with these modules, that repository is called as a local repository. Here, if everything associated with the entire project has been stored, that repository is called as a global repository. Okay, so please make a note. Now we have discussed about the terms associated. You know what is server. Okay, being the Git at GitHub is a client server architecture. The machine where the user is working with is called as a client, and the machine where all the files associated with the particular project has been stored has been termed as a server. Okay, so under which we have repositories. In terms of repository, we have two types of repository. One is the local repository, another one is a global repository or remote repository. The repository is nothing but a container which is used to store the files associated with the particular project. What are all the files the user is dealing with? The corresponding files will be stored in a location in his computer. That location is local repository. So all the user will share the file and store the file into the global repository. Okay, and we have another thing called as workspace. Workspace is nothing but the location where the user is working with. Okay, this is called as workspace. So we have already discussed about the check-in, commit and update. Okay, and push and pull commands. So these are all some of the terminologies associated. So what is a check-in? What is a checkout? So let me discuss. We have a concept called as check-in and checkout. The check-in is called as a commit. The check-in command is called as a commit. Checkout command is called as update. Let me discuss. Okay, apart from that, push and pull command. So here from the working location, from the workspace, the file need to be moved into the local repository. For that, we need to issue a command commit. We will have all the things practically explained. Okay, just make a note. I will let you know practically. From the user's workspace, from the local workspace, if you want to move the file, once the working copy of the file, if it need to move to the local repository, then you want to use a command called as commit. If from the file need to be moved from the local repository into the global repository, you want to use the command push. The difference between commit and push: commit is used to move the file within the computer from the workspace into repository. Then push is used to move the file across the computer from the local computer, that is the client computer, into the server computer. Please make it out. I will explain more details. Let me imagine we are developing a particular product, okay, a software product. So let me imagine the same banking application. Let me develop a banking application. So under which you have a client. These are all the users associated. User 1 is having file 1, file 2. So file 1, user file 3 and file 4, and user is file 5. Okay. So here under the user location, the file will be stored under a repository called as local repository. Each and every file. If the user want to work with the file will be placed on the workspace. The workspace is the location where the user will do all the changes. If you want to add, if you want to compile, all the thing will be done on the workspace, and laterly it will be stored in the local repository. Okay, how to store, how to move the file from the workspace into the local repository. So what the user will do is, from the workspace you want to issue a command called as add. It will take it to the intermediate location. Okay, it will take it to the intermediate location. This is your local repository. This is your file 1. When you issue add command, this file 1 will be taken from the workplace, and it will be stored in an area called as the staging area. This area is called the staging area. It is a temporary area. Here, from the staging area, if you issue a statement commit, it will be stored in the local repository. Okay, all the file 1 will be moved into the local repository. So imagine, let me create a file 1, echo. Okay, let me create a shell file, f.sh, a simple shell or any Java, whatever may be. Echo line 1 is the first command. Okay, you have file 1. Initially, the file will be created where? Under the workspace. Okay, so when the add command is given, the file 1.sh will be moved into the staging area. Here it will be taken as snapshot. Snapshot is nothing but the backup copy of the file. The file will be taken backup. Snapshot you call backup as a snapshot technically. The file will be taken in the stage area, and it will maintain a snapshot in the stage area. From the stage area, if a commit command has finished, it will be stored in the local repository. Now you have file f1.sh. The user want to do some modification on the file. What it will do? So he want to retrieve the file from the local repository. He open the file 1.sh. So he is going, already the file containing line 1. He is going to add another line, echo line 2. In this case, the file which is present in this workspace is different from the file present in the local repository. Yes. Here, what the user want to do. So you want to, once the needed changes has been made, this is the version 1 of the file. you want to maintain this copy as a version 2. Okay, we have now file 1, version 1. So the user after did the changes in the workspace, if he see the add command, the file will be moved in the staging area. So in the staging area, we have already the version 1 of the file f1.sh. It will make a comparison. What are all the changes? Again, it want to take a snapshot here also. It want to take a snapshot here. Whether it will take a full backup or incremental backup, it will take an incremental backup. Okay, that is that we call it as a lightweight component. So Git is a lightweight component. While taking this backup, it will make a comparison with the old version. These two things will be compared. What are all the changes that we did? That alone will be taken backup. Example, we have only line 2 alone will be stored in the version 2. Okay. So what are all the changes? That changes alone will be taken backup. After that, if the user issues the command, that it will have file 1.2 version 2 .sh will be stored in the local repository. So this is the way by which the workflow from a workspace into the staging area. What activity will be done in the staging area? In the staging area, it takes the snapshot to maintain the version. Okay, it will compare the previous version and what are all the changes that is made. That changes alone will be taken. This is called as a lightweight component. We call this Git as a lightweight because of the following incremental backups. Please make a note. These are all interview questions. So this is the way by which from a workspace you will move the file into staging area, and from staging area by issuing a command called commit. These are all the commands. Add is a command, commit is a command. That commit will save the file, move the file from workspace into the local repository. Here we have two things: check-in and check-out. Also, we have discussed about check-in and check-out. So, what first the user will do? So, workspace, is a working directory in the client computer. Okay. So, here the user first what you need to do, you want to create the workspace. The first command, we will create a workspace. After creating the workspace, here now you need to move the file from the local repository or from global repository into the workspace. The process of moving the file from the repository into the workspace is called as check-in. Please make it. Sorry, the process of moving the file from the repository into the corresponding workspace, the workspace of user Raman. Okay, so is called as checkout. Check-in refers to once the file is brought into the workspace, after modification, the file need to be moved from the workspace into the repository. This is called as a check-in. Please make. Checkout means moving the file from repository into workspace. Check-in means after did the needed change from the workspace into the repository, we will perform check-in and check-out. Here, the command that we used for performing check-in is the commit command. The command that we use for check-in is called commit command. How a check-in and check-out differs from a push and pull. Okay, from the local repository, if it want to be stored under the global repository, then you want to use push command. Push moves the data, moves the file from local repository into global repository. Pull is a reverse, moving the file from the global repository into local. Please make a note. These are all interview questions. Push and pull is associated with moving files across a local repository to global repository and vice versa. Check-in and check-out associated with moving the files from workspace into local repository and vice versa. Please make a note. For each and every check-in, okay, so here check-in is called issued by commit. Each and every check-in, when you do some modification, file one dot let me make it Java. If you commit the file, okay, the file will be committed with a commit ID, a unique commit ID. A 40 character commit ID will be assigned to the file. This commit ID will contain all the informations. So who made the change, when the change has been made, so the what is the date and time the change has been made, what is changed, what is the reason behind the change, everything will be recorded here in the commit ID. So by looking into the commit ID, you can able to go through for what reason, by who, at what time, and the change has been made. Okay, you please make a note. The commit ID is unique. For each and every commit, we have a unique commit ID. The commit ID is of 40 characters in size. So we have also aware of what is a snapshot. Snapshot is nothing but the backup, lightweight. Okay. Here for this commit, we use the algorithm. So for this commit ID, the commit ID is generated using an algorithm called as SHA-1. Please make a note. It's some a hash function. I will let you know what is hash function. The algorithm used is SHA. It contains the following description: who, when, what is the reason. Everything will be specified here. Here, apart from that, we have several status associated with the file. The file can be a unmodified file. The file status may be unmodified. The file status may be a modified file. The file may be an untracked file. The file is a tracked file. The file may be a staged file. Okay. The file status. The files associated with the GIF can have the following status: unmodified, modified, untracked, tracked, and staged file. Okay. Imagine this. You are having your workspace. Okay. You know what is workspace. It's the location that the user will do the needed activity. Okay. This is your workspace. Intermediately, the target is your local repository. This corresponds to user 1. Okay, let me take this corresponds to user 1. Raman's desktop. We have workspace. Intermediately, we have a stage area. So first time, Raman is creating a file. A file name is file1.java. So now we only have the copy of the file in workspace. We won't have the copy in the local repository. At this stage, the file1.java is called an untracked file. Okay, file1.java is called untracked file if it does not have a copy on the local repository. If it is having a copy on a workspace, the file is untracked. Okay, so after creating the file, what we will do? you will issue a add command. The file will be moved into the staging area. Now the file 1.java is said to be in a staged file. We call this file as a staged file. File 1.java as a staged file. In the staged file, in this stage area, we will be taking a snapshot. The file will be taken a snapshot. And after that, if you issue a commit command, the file will be updated to the local repository. Now, if you have the file f1.java in Workspace and local repository, and if the file, both the file contain the same content without any difference, then the file is said to be an unmodified file. Okay, the file is said, if the content of the file is the same in Workspace and also in local repository, we call it as unmodified file. Okay, this is on Monday. On Tuesday, Raman did some changes. Okay, in file 1.java, it did some changes. Opened the file 1.java and added some new contents on top of it. And laterly, so here this file 1.java now containing version. Let me make it. This is the original. This corresponds to first version file 1.1.java. Now in your workspace, you have this updated file. In your local repository, you have this original file. Here the file in this perspective is different from the content which is present in local repository and the content which is a modified content in the workspace. Now the file is said to be a modified file. If the content of the file is same in both the workspace and local, it is said to be unmodified. If the content is differ, it is said to be modified. If the file is present only on the workspace and if the file is not present on the local repository, we call this file as a untracked file. If we have the file present in workspace as well as local repository, we call the file as a tracked file. If the file is moved from workspace into the staging area where it is taken snapshot, the file is called staged file. So these are all during the flow from the workspace into the local repository, the file will have the following status. Please make a note. This question was asked for an architect level in the last week in Accenture. What are all the various stages, and let you specify the workflow starting from the user creating the file and moving the file into the local repository. So these are all some of the basic process associated with creating a file, taking a backup and moving the file into the local repository. Okay, we can have our once more, we can have our next session on the same time tomorrow morning. No issue. We will continue what are all the things that is discussed theoretically. Tomorrow we will continue how to install Git, how to work with the following commands, how to create. Okay. So probably I will share to you. So there is yesterday I had tried to upload it, but I couldn't upload. So I will upload today, and you will receive the video before tomorrow's session. No issue. Abhi, Madhu, Shanmugam, Sri, I will share you all the needed things within tomorrow. Okay. Tomorrow the same time, 6:30 to 7:30, we will be having the session.
Okay.
Okay. Thank you. Thanks a lot.
Thank you.
So you please, even though I share you the recording, you please have a habit of taking note of all the associated things what we are discussing, so that it will be helpful.
Sir,